In this question from the chapter relation, it says A is a set that is equal to Z plus. That means Z plus stands for the all non-negative integers. aRb, if GCD of AB is equal to 1, we have to determine whether this relation is reflexive, symmetric, or transitive. Now, before we proceed, you should know that GCD stands with the greatest common divisor, which is same as HCF. Further, you should also remember that what are co-prime number. Like if I take, first let's say if I take two numbers, say 35 or say 33, and I took 15, the factors of 33 is what? 1, 3, 11, right? And the factors of this is what? 1, 3, 5. Now, if I include 33 also and 15 also, so the highest factor is what? 33. So we'll say that GCD is 3 here. Now, if I take instead of 33, if I say 16 and 15, the factors of 16 is what? 1, 2, it's 4, 8, and 16 itself. And for 15, it is 1, 3, 5, and 15 itself. So what you can see here, 1 is the highest factor, highest common factor or greatest common divisor. So we'll say that these two are co-prime. That means two numbers are said to be co-prime if they have no other common factor other than 1, or we can say that if the greatest common divisor is 1. Now we need to prove whether it's a reflexive or symmetric or transitive. Now, if I take is replacing A with B, that's what we do in case of reflexive. Let's say aRa is what GCD of A comma A. Is it equal to 1 is what we have to decide. Now, if I take two numbers, let's say I take two same numbers, like say if I take 6 and 6, the factors of 6 is what? 1, 2, 3, 6 itself, 1, 2, 3, and 6 itself. So what we can see that for the same number, the greatest common divisor is the number itself. So it should be A and not 1. The greatest common divisor of two same number has to be the number itself. So it is not coming as 1. So we can say that it is not reflexive. Now coming to the symmetric, it says, given that considering that aRb implies that GCD AB is equal to 1. So what does mean that? As I said, when GCD of two number is 1, it means they are co-prime. That means they do not have, so we can say A and B are co-prime. Co-prime means they do not have any common factor other than 1, and we'll consider 1 to be the highest common factor or greatest common divisor. So if A and B, or the GCD of A and B is 1, it also implies that the GCD of BA is also 1, right? That means BRA is also true. So we'll say that it is symmetric. Now for transitive, we will take three numbers, let's say A, B, C, and these all belongs to set A, which stands for Z plus. Now considering aRb, let's say I write aRb, which implies that AB such that, right? It is such that a GCD, right? It's GCD of AB is equal to 1. That means A and B are co-prime. And we have BRC also given such that GCD of BC is also 1. Implies that AB, the meaning from here that AB are co-prime, and from here BC are co-prime. So it implies what? If I say AB are co-prime and BC are co-prime, that means AC will also be co-prime. Co-prime. So we conclude that the highest common factor of AC is also going to be 1. So let's say, for example, if I take three numbers, let's say 3, 5, and 16 only. So these two are co-prime because the highest common factor between 3 and 5 is 1. The highest common factor between these two is 1. So the highest common factor between 3 and 16 is also going to be 1. Now see the contradiction here. Like instead, if I take a number that has a common factor of 3 but not of 5. So I can choose for a number that has a common factor of 3 and that not for a 5. So I can say 36. Now check here. So what the common factor of 1, GCD of 3 and 5 is what? 1. GCD of 5 and 6 is also 1, but GCD of 3 and 6 is 3. So we'll say that it is not transitive. So you can give an example instead of saying that AC is co-prime. You can give an example of contradiction. And I think this is better if you can show that A is equal to 3, B is equal to 5, and C is equal to 36. You can show that GCD of 3 and 5 is equal to 1. And same way, GCD of 5 and 36 is also 1. But then you have to show that GCD of 3 and 36 is 3. And that is not equal to 1. And therefore, you should say that it is not transitive. Hence, we can say it is symmetric. Symmetric is correct, but it is not transitive, nor it is reflexive.